Section 6.2 is formulas. In this section, we're going to talk about evaluating a formula and also rearranging a formula so that it looks different and a different variable is isolated. A formula is just going to be an equation. Typically, it has a real-life application. If I ever ask you to evaluate a formula, I typically call it plug and chug. All you need to do is to substitute the given values in to the variables they're supposed to represent, and then use the order of operations to simplify the expression. One common formula that you'll use in this chapter and others is the simple interest formula. The simple interest formula is interest equals principal times rate times time, or we'll just call it I equals PRT. You're going to use this to calculate interest on a simple interest loan. The principal is how much you've borrowed at the time of the loan. The R is the interest rate, and that must be rate as a decimal. And then T is time. Typically, the time will be given in years. So Fatima borrows $4,000 at a simple interest rate of 2.9% for 3 years. How much will she pay in interest at the end of 3 years, and what is the total amount she will repay the bank at the end of 3 years? Okay, so to do part A, you have to find how much interest she's going to pay. And to calculate her interest, you take the principal times her interest rate. Now, 2.9% is going to be 0.029 when you do it as a decimal, times the number of years of the loan, which is 3. And this is going to tell you how much interest she's going to owe at the end of 3 years, which is going to be $348 in just interest. And then question B says, how much is she going to have to repay, the total amount? Well, she borrowed $4,000, so she's going to have to pay that back. Plus, she has to pay them the interest on the loan, so she's going to pay them $4,348 total. Another common formula is volume. So the formula for volume of a rectangular box is to take the length times the width times the height. In symbolic formula, that would just be V equals LWH. So we are looking for the volume of a rectangular ice cream box that has a length of 7 inches, a height of 3.5 inches, and a volume of 122.5 inches. That should say cubic inches. It should be an exponential. Okay, so we know that volume equals length times width times height. In this problem, the volume was 122.5. The length was 7. The width is unknown, and the height is 3.5. So what I would recommend that you do is on the right-hand side, multiply the 7 times the 3.5. If you do that, 7 times 3.5 is 24.5. So you just used the commutative property of multiplication that tells you you can rearrange the numbers in any order you want if they're multiplied. And then you're trying to solve for the width of this box. So W is being multiplied by 24.5. So the opposite operation would be to divide by 24.5. So grab your calculator and do 122.5 divided by 24.5, and you'll find that the width is 5. Now remember, length, width, and height are measured in inches. Volume's cubic inches. When we represent a real phenomena, like we just did with simple interest, we say that we've created what's called a mathematical model. Some people just call it a model. A model can be a formula, it can be an equation, or it can be a set of equations. Many formulas contain Greek letters such as mu, sigma, the capital sigma, delta, capital delta, epsilon, pi, theta, and lambda. So when you guys go off to your 4-year college, many of you will learn the Greek alphabet. These are some very common ones that you're going to see in this class. A statistics formula that we will use later on this semester is going to be one to calculate the z-score. So to calculate the z-score, you take x bar minus mu and divide it by sigma over the square root of n. This is just an evaluate problem. They want us to find the z value when x bar is 120, mu is 100, sigma is 16, and n is 4. So let's make our plug and chug substitutions. So z equals x bar minus mu divided by sigma over the square root of n. Okay, so in this problem, they've told us that x bar is 120, mu is 100, sigma is 16, and n is 4. When we get to our statistical unit, all of this will make more sense as to what these numbers represent. When you go to simplify this, you want to simplify the numerator first. 120 minus 100 is 20. And then you want to simplify the denominator separate. The square root of 4 is 2. And 16 divided by 2 is 8. And then 20 divided by 8. You can either get a decimal if you want, or you can leave it a fraction. You'll have to pay attention to what the computer is asking you for, is 2.5. Sometimes the problem will use subscripts. Subscripts can be numbers or letters that are going to be placed below and to the right of a variable. So for example, you could have an A, you could have an A sub 0, an A sub 1, an A sub 2, etc. It's just for clarification to distinguish between different values. You don't mathematically do anything with those subscripts. Sometimes you're asked to solve a variable for solve the formula for a specific variable. So you'll be given a formula or an equation. It'll be expressed in terms of a variable, and you're asked to express it in a different variable. So to do so, you're just going to treat each of the variables as if they're constants, except for the one that you're solving for, and then you want to isolate the desired variable. So for example, I gave you the equation 2x plus 5y minus 10 equals 0, and I've asked you to solve it for y. So your goal is to get the y on the left-hand side of the equation with nothing else with it. So first thing I would do is I would subtract the 2x to the other side. I would add the 10 to the other side. You cannot combine these as like terms because the 10 doesn't have an x with it. And then last, to get the y alone, it's being multiplied by 5, so you would have to divide both sides by 5. And so now your y would be isolated, and your y would be equal to negative 2x plus 10 all over 5. You can write that in a different way if you wanted to. You could write it as two separate fractions, which a lot of people do. So if you had 10 over 5, that would simplify to 2. Either answer is correct, and my math lab should accept either answer. Let's look at one more. Z equals x minus mu divided by sigma. And I've asked you to solve for x. So remember, typically we do not like fractions, so I would recommend that you clear the fraction first. To clear the divide by sigma, you would multiply both sides by sigma. So that would give you sigma z equals x minus mu. And then to isolate your x, you would add mu to both sides. So sigma z plus mu equals x. Once your variable is isolated, you have solved the formula.